Hello, everyone. My name is Lisa Chernenko. I'm a DPhil candidate in social data science here at the OII. And welcome to our seminar titled From Tribes to Tropes, Network Polarization and False Consensus Around COVID-19 Science. We are delighted to have Dr. Alexandros Efstratiou with us today to discuss his recent work showing that COVID-19 science was vastly misrepresented on the Twitter platform, owing mostly to a large misinformation cluster that engaged in selective citation of scientific papers. Alexandros is an incoming postdoctoral fellow at the University of Washington Center for an Informed Public. His doctoral work examined the dynamics of intergroup and intragroup polarization on online social media, with a focus on how these relate to the propagation of misinformation on hostility in these spaces. And as part of his research agenda, he also examines social psychological phenomena at scale, as well as meta-science and science communication using computational social science tools. His current research focuses on outgroup misperceptions and outgroup directed misinformation. For your awareness, this event is being recorded and will be posted on our website following the event. This presentation will run for about 30-40 minutes, followed by a discussion at the end. Please put your questions into the Q&A box, and Alexandros will answer them after the talk. If you wish to ask your questions with your mic, please raise your hand during the Q&A, and we will call you on. Be aware that this will be included in the recording as well. So it's really great to have you here, Alexandros. The floor is all yours.
Thank you very much for that introduction, Lisa, and thank you all for inviting me. This is a great chance to be here and to talk to you all about my work. So I'm just going to try and share my screen. Hopefully this will work. So is that okay? Can everybody see the slides? Great, fantastic. Okay, so yeah, again, it's a delight to be here, and thank you all for attending this talk. So my talk will be on network polarization and false consensus around COVID-19 science, specifically on the Twitter platform. Before I start this talk, I would just like to thank the people that made this project possible. So my co-authors on this work, Marina Efstratiou, who's also incidentally my sister, Satrio Yudhodmojo, Jeremy Blackburn, and Emiliano De Cristofaro. And this was a joint work between UCL and Binghamton University under the umbrella of the iDrama Lab. So the agenda for today's talk, we will start with a brief introduction to the problem of science communication in general and misrepresentations of science. And then we will look at some research questions, effectively how we framed the problems for the paper. We will also look at the data and the methods we collected and how we address these research questions. And then we'll go into talking about the results and specifically the implications of those results, both for practitioners, for us as researchers, and for the public in general. The citation for the paper that I will be talking about today is here at the bottom, but I've also added a QR code at the end if you're interested in reading the full paper, so you can just scan that if this is of interest. So just to briefly introduce the problem, when we think about misinformation and where it comes from, we tend to think about kind of untrustworthy news outlets, perhaps, or untrustworthy people or influencers that do not really spread vetted information. And these are just some examples of outlets that tend to be perceived as untrustworthy. But occasionally, and specifically in scientific circles and COVID-19 in particular, misinformation has also come from perceived experts. And these are just two examples from CNN and The Guardian, different headlines, basically talking about perceived experts like physicians, or in the case of Florida, their Surgeon General, spreading things that the scientific community would not agree with regards to COVID-19 vaccinations. And so occasionally this misinformation can actually have sources that would be perceived as being credible, or at least having some credibility to talk about these kinds of topics. And this kind of motivated some early work that we did back in 2021 around preferred experts and how they are talked about in public circles. So in this particular case, what we wanted to do was we wanted to look at Nobel Prize winners in physiology or medicine. And we wanted to basically examine whether these Nobel Prize winners, who have a lot of public trust to talk about topics around medicine and health, we wanted to look at whether they express some kind of public opinion on COVID-19 vaccinations. And so when we searched the web to see any kind of public statements that they made, we found that 24 medicine Nobel laureates publicly placed themselves in favor of vaccines, and just one Nobel laureate placed themselves anti-vaccines. So we then took these names and we searched for Twitter. We searched on Twitter for these names co-appearing with the terms COVID-19 and vaccines. And what we would have expected in this particular case would be for 24 out of 25 tweets talking about these laureates in the context of vaccines to be about the pro-vaccine laureates, and just 1 in 25 tweets to be about the anti-vaccine laureate. And the preliminary findings actually painted a very different picture, because what we saw was an almost complete reversal of this expected frequency. So 95% of the tweets that we found were actually about the one laureate that opposed vaccines. And most of those tweets were actually favoring this laureate. And just 5% of the tweets were about the pro-vaccine laureates. And so this was just some very early evidence that spoke to us and said that perhaps representations of expertise and science in general in public circles may not necessarily follow scientific consensus. This is something that has been talked about extensively in other scientific topics as well, like anthropogenic climate change. So, expertise in science has been misrepresented in several other topics. And this is Cook et al. Speaking on anthropogenic climate change back in their seminal paper in 2013, where they found that 97% of published research on anthropogenic climate change is endorsing the consensus position that humans are actually causing global warming. And they verified this with a follow-up survey with the actual study authors. However, we actually see a headline here by the Epoch Times, which is another outlet that occasionally tends to share untrustworthy news around scientific topics specifically, where they are painting a different picture. They are saying that climate change agendas essentially and narratives were based on faulty temperature data, climate experts say. So again, we see this idea that you can always find another expert that will say something other than what the consensus position may be. And it's quite easy to obfuscate this scientific consensus in the absence of other data that could tell us how many scientists or how much of the research base is actively supporting one or another position. And so sometimes scientific consensus itself can be misrepresented, not just by drawing on experts, but also drawing on people, on papers themselves, on scientific evidence itself. So here is a person on Twitter saying that they have been branded a misinformation spreader because they've been saying that COVID-19 vaccines are not safe. And then they say, now the medical peer-reviewed literature shows that I was right. And they basically pose a link to a study that kind of supports this idea that COVID-19 vaccines may not be safe. And another person responds to them saying, so you'll trust the meta-analysis of 58 worldwide studies I can send you, or do you just want to cherry pick one? And so we're seeing the same idea in now the context of scientific evidence itself. So we can find several papers to support different positions. Of course, in science, we tend to do things differently with different methods. And so occasionally we'll have different findings. But again, what is really the consensus position? How can we represent that? And so this is where our work came in. And the first question we wanted to ask was, first of all, is the scientific consensus around COVID-19 misrepresented on Twitter? And crucially, by how much? So we wanted to quantify this effect. Secondly, are certain sources disproportionately driving these public discussions of COVID-19 science? And third, how does COVID-19 scientific discourse evolve over time on Twitter? So the temporal dynamics of these public discussions of COVID-19 science. And finally, in what other ways can COVID-19 science be represented or even misrepresented? And this basically formed the basis for our study. In terms of our data, we first of all started by collecting 25.3 thousand preprints on COVID-19. So for this, we used a COVID-19 paper repository that was co-hosted by the bioRxiv and medRxiv preprint servers. So they are preprint servers basically specifically on the fields of biology and medicine. And so we obtained all of these papers from the COVID-19 paper repository, and then we queried the server APIs themselves to obtain further information on these papers. We found that 13.4 thousand of those papers later went on to be published after peer review. using these paper identifiers, we then also queried the Altmetric API. So Altmetric is a service that provides popularity data on papers, things like citations, number of news mentions, number of Twitter mentions. And Altmetric also provides us with tweet IDs of the papers that, tweet IDs of tweets that are mentioning these papers. And so using these Altmetric APIs, we were able to obtain some tweet IDs that we then hydrated through the official Twitter API. And we obtained 1.24 million tweets talking about these papers from 346,000 unique users. And so our final data set consisted of paper popularity data straight from Altmetric, but also Twitter data talking about these papers from Twitter itself. I should also say that we collected this data back in November and December of 2022. So that was before the rebrand to X occurred. And that was actually before any major platform changes happened to Twitter. So it still functioned mainly like the old Twitter at the time. As a first step, we wanted to obtain some topics that these scientific papers were talking about. So we analyzed the entire corpus of paper abstracts using BERT topic, which is considered kind of a state-of-the-art topic modeling technique. And we found several different topics that these papers are talking about. In fact, there's 52 different topics here that we were able to classify papers into. But of course, with this many topics, what we later wanted to do was to focus on the highest important categories, the categories that basically people talk the most about on Twitter. And so we merged some of these categories, and we ended up with with 4 latent mega categories that we then focused on to analyze further. The first was vaccines. Second were non-pharmaceutical interventions, so things like mask wearing, lockdowns, socially distancing, etc. The third were COVID-19 dangers. So the idea of how dangerous is COVID-19 in terms of its mortality rate, its risks for long COVID, neurological damage, etc. And finally, drugs. So prophylactic and therapeutic drugs. And this encompassed things like remdesivir, hydroxychloroquine, ivermectin, etc., and any evidence that spoke about these drugs. After we obtained these topics, the next step was to actually classify our user stance towards COVID-19. And so we framed this problem as a node classification problem using a graph convolutional network on the retweet network. So as training features for this, we used the network adjacency matrix. So effectively, this is just a table that shows which users every user in the network is connected to. And we also used the 2D node coordinates after Force Atlas 2 visualization. Effectively, we just drew the network using this spring layout algorithm. It's a spring-like layout algorithm, and we looked at it, and we figured out that there were actually 2 super clusters, and they reflected a pro-consensus and anti-consensus cluster. And so we used these 2D node coordinates to amplify our training features. As ground truth for this task, we actually used annotations of users based on 3 or more of their tweets. So our ground truths were not node positions in the network, but they were actual tweet contents. And we were able to classify whether users were espousing or opposing consensus positions in this particular case. And after we ran these models with this data, we performed 5-fold validation and were able to achieve 98% average accuracy across all of the folds. Now, the resulting network that we obtained from this exercise, you can see here. So on the left-hand side, the red cluster are the anti-consensus users. So the anti-consensus cluster, we called these people contrarians. And then on the right-hand side, the blue cluster, the bigger one, are the pro-consensus users, the pro-consensus cluster that we call the conformists. And about 30% of the entire network are actually contrarian users, which is actually quite a substantial number of the entire network. So after obtaining these user stances, our final step was to derive scientific consensus on COVID-19 and false consensus as a result of that. So to do this, we first of all annotated 200 randomly selected papers per category. And the target of this annotation exercise was whether the conclusions of these papers supported or opposed official guidance. And as official guidance, we use the World Health Organization's recommendations for all sorts of different things on mask wearing, lockdowns, drug prescriptions, vaccinations, etc. We then calculated the scientific consensus ratio based on these samples. So for example, out of 100 papers talking about vaccines, if 5 out of those 100 said something about vaccines not being effective or being too high risk, then the scientific consensus in that case would be 95% supporting the official guidance or the consensus position, and 5% of the papers opposing that position. And we then derived our false consensus metric by dividing the public consensus that we obtained from the retweet network in the previous step for that particular topic with the scientific consensus we obtained using this annotation exercise. As a final step, and this will become clear why we did this a bit later, we also annotated the top 20 most mentioned papers on Twitter for each category. So in terms of our results, is there actually a false consensus? And I assume that the eagle-eyed among you may have already reached a conclusion on this, but unfortunately the answer is yes. And this is a table that I pulled straight from our paper, but I'm not going to go through the entire table. I just want to draw your attention on the vaccines topic because that was by far the most glaring example of this false consensus. So when we look at the vaccines topic, we find that the percentage of contrarian papers, or contrarian consistent papers at least, on this topic was 4.2%. So 4.2% out of the papers that we annotated opposed official guidance on vaccinations, either finding that vaccines may be too risky or finding that vaccines are inefficient, etc. I should actually also put a bracket here and say that these papers are not necessarily contrarian in the sense that the authors themselves are contrarian. Some of these papers were actually quite useful towards informing public health, for example, finding some association between vaccines and myocarditis, but we labeled them as contrarian consistent because they're papers that could actually be used to fuel a contrarian sentiment. Now, so 4.2% of these papers kind of oppose this consensus position, but when we looked at the percentage of contrarian tweets or users in the network, we found that over 45% of those were talking about this 4.2% of papers. And so this leads us to a discrepancy factor of over 10 times. Okay, this is quite substantial because when we look at the effect size arising from a chi-square test where we set the expected frequencies on this scientific consensus here, we get a Kramer's phi of over 2. So anything above 0.5 in this case would indicate a large effect size. So you can imagine that this is actually 4 times more than what we would need for a large effect size. So this is a massive effect size. Now, previously I said that we also labeled the top 20 papers that were most mentioned on Twitter per category. And the reason we did that is because we wanted to see whether these most mentioned papers were disproportionately driving these discussions. And when we looked at the top 20, and not top 20%, I want to stress that, just the top 20 papers out of thousands of vaccines papers, we found that 50% of those top 20 papers were actually contrarian consistent, as opposed to just 4.2% in the random sample. And this is actually substantial because when we look at the cumulative percentage of Twitter mentions that these papers get, we've drawn this horizontal line here to indicate this top 20 papers, the point at which they accumulate Twitter mentions. So when we look at the vaccines topic in this red line here specifically, we see that these top 20 papers alone, out of thousands of other vaccine papers, accumulate over 30% of the total Twitter mentions for that topic. And this is also the case for the other topics where we observe cumulative percentages of up to 70%. For these top 20 papers. So these most mentioned top 20 papers are actually massive drivers of the discussions around COVID-19 on Twitter. And so they may actually be driving these discussions disproportionately. But our next step was to actually try and quantify that a little bit more strictly. And so to do that, we wanted to ask whether certain sources are primarily responsible and the types of sources. And we found that certain sources are primarily responsible for driving these conversations on Twitter when they are primary, so when the source is a paper, as we just saw. And the specific quantification of this was that when we were drawing a random anti-consensus paper from our pool, it would have more Twitter mentions than a randomly selected pro-consensus one, 68.5% of the time. So papers that were contrarian actually had a disproportionate effect. But this was not the case when the source was secondary, so when the source was a user or a tweet. So contrarian users or contrarian tweets, they tended to actually accumulate pretty much the same number of retweets as conformist users and tweets. And we also ran some regressions to look at this a little bit more deeply. And this is a multiple regression we ran for the predictors of the paper number of Twitter mentions. where we found that the biggest predictors of the number of Twitter mentions for a specific paper were, first of all, whether the paper is contrarian or not, and that actually demonstrated the largest effect. The number of news mentions that the paper accumulated, and unfortunately, I can't really speak to the direction of this effect. I can't really say whether papers with more news mentions would then get picked up more on Twitter, or if the news outlets themselves picked up on papers that were already gaining traction on Twitter. It's something we're working on at the moment. And also, the more recent a paper was, the more likely it would be to get more Twitter mentions. In terms of the predictors of tweet level number of retweets, however, so basically the traction that different retweets got, this multiple regression basically flagged pretty much everything as significant because we used quite a lot of data points. Again, there were over 1 million tweets, but the two predictors with non-negligible really effects were the number of followers of the tweeting account, and whether the account was verified or not. And both of these things make sense. So number of followers, of course, if you have more followers, then your tweets will get picked up more. And whether you're verified or not, again, we collected this data back when verification on Twitter was done manually and basically verified whether the account belonged to the user that it purported to belong to. It was before you essentially paid for the blue badge. And so the verified could have been an indicator of trust in the account in that sense. So in this particular case, again, going back to that original framing, yes, primary sources do disproportionately drive Twitter discussions when they are contrarian, but this is not really the case for contrarian users or tweets. We also analyzed the temporal evolution of this COVID-19 discourse, and here are two plots showing the volume of tweets over time and the volume of preprint releases over time. We see that especially near the start of the pandemic, these kind of peaks and troughs pretty much follow each other, but as the pandemic progresses, preprint releases tend to follow more of a stable cycle, whereas volume of tweets, they are a little bit more erratic in that sense. However, one of the more interesting, I would say, findings in terms of the temporal evolution of the discourse is the volume of user signups over time. So when we look at the volume of conformist and contrarian account signups from the beginning of Twitter, so you can notice that the axis here start from 2006 when Twitter was formed, we can see that the peaks and troughs for conformists and contrarians are effectively the same over time. So it's just contrarians are signing up at the same rates as conformists, but just with a multiplier that lowers that prominence, right? So we can see that the same peaks and troughs tend to co-occur for both groups up until about a year into the pandemic. So 2021, March 2021. So in this case, we can actually see that beyond this point, contrarian account signups begin to overtake conformist account signups, which is actually quite interesting because that might speak to the idea that there was effectively an injection of contrarian users that could have been used to obfuscate a scientific consensus and amp up this false consensus effects we describe, perhaps in an organic or inorganic manner. We performed a few more analyses of the activity of these users that signed up later on during this time, and we found effectively that their activity tried to amplify already prominent voices in the contrarian cluster. We can't really say whether the activity was organic or not. We unfortunately could not collect further data up to at that point. It was around the time when the Twitter API was no longer available. But if you're interested in reading more about the activity of these particular users, we have done a few more analysis in the full paper. And finally, we also wanted to qualitatively assess how COVID-19 science is represented or misrepresented. And we specifically focused on pro-consensus papers that were mostly discussed by anti-consensus users and vice versa. So in this plot here, this 3D scatter plot, we effectively focused on the regions that I've just circled right there. So papers that were annotated by us as being contrarian consistent, but picked up by pro-consensus users, and papers that were labeled by us as being anti-consensus, being picked up by pro-consensus users. And so we also focused only on papers with over 100 Twitter mentions because we didn't really want, we wanted to eliminate the possibility that these differential distributions of users talking about them were due to some artifact of lower numbers. And then we performed a qualitative content analysis on the tweets. So our strategy we followed here was we compared the claims made in the focal paper to the claims made in the tweets that were citing that paper. And I'm going to give a very brief overview of our results. So what were the qualitative themes that we were able to derive? The first and most prominent one was the cherry picking of results. So for quite a few papers, what we saw was that users would go into a paper and they would pick up a specific finding that paper made and then take that out of context and spread it with zero regard for the rest of the findings or how really the paper interpreted that finding. And this was by far the most common strategy when we were looking at this analysis. We also found that certain users would discredit or diminish findings, and there were two main ways in which this was done. The first one were bad faith accusations of researchers. So we found cases, for example, where users would accuse researchers of being paid by different entities to make certain claims around, for example, the idea that hydroxychloroquine is not a safe drug, etc. But we actually also found that certain people would critique the study methods themselves. So we also saw some deeper methodological and scientific discussion on the Twitter clusters, where people, mainly actually researchers or scientists themselves or science communicators, would pick up on different papers and then explain the limitations in the methods that they used. And so these were slightly deeper discussions, actually, and sometimes even discussions that you would find in a limitation section in an actual published paper. So they were deeper level. We found some cases of people focusing on contextual implications. So, for example, looking at the cases where a drug would be prescribed as kind of a combination with another drug. And the final theme was disseminating science for public benefit. And this was a behavior that we observed exclusively for pro-consensus users, where occasionally some papers would come out and say things like vaccines are not as effective against newer variants, etc. And so pro-consensus users would actually take these papers that you could argue would harm their bottom line, I suppose, that vaccines are ineffective, etc. And they would actually disseminate them to urge people to continue to get vaccinated, but urging people to also follow other protective measures like wearing masks and keeping your distance, because vaccines will not fully protect you against COVID-19. And so we could kind of say that we found both misrepresentations of science in terms of cherry picking and bad faith accusations of researchers, but also representations of science in terms of critiquing the methods, focusing the contextual implications of the results, or even disseminating science for public benefit. I just wanted to give you an example of a cherry-picking a study that was heavily cherry-picked, and this is a comment that was made by the study's author on medRxiv. So, in this particular paper was analyzing the prevalence of long COVID, and they also made kind of an off-site finding that vaccination increases the odds of having long COVID, and this was one of the findings they reported. Now, Twitter basically went really ballistic with this finding, and most people would focus just on this particular aspect of the vaccinations with regards to long COVID odds. And this prompted the author of the study to post a comment on medRxiv saying that this finding, that this vaccination increasing the odds of having long COVID, is probably due to the presence of something called collider bias, which effectively arises when you focus on a particular sample that is not really representative of the wider population. So in this particular study, they only looked at vaccinated people. They only looked at people that tested positive for COVID-19 that actually seeked out hospital services. So that was a very kind of specific sample. And this author goes on to present more information, more references around this finding and the contextual implications of the collider bias, and they also present more references to that really just analyzed vaccination with respect to long COVID odds that found opposing results to them. And then at the end here, this is effectively the reason I present this example is because it really exemplifies what we're trying to say through the cherry picking aspect. The author says it is unfortunate that knowingly or unknowingly readers are cherry picking this finding to confirm their own beliefs without seeing the overall evidence. And this is just an example to say that very occasionally Twitter users would go against authors' own interpretations and advice and take their own findings completely out of context to make certain claims that aligned with their own beliefs. And just to give you a little bit more context around that. So just to summarize our main findings, we found that science is unfortunately severely misrepresented. We found some pretty strong false consensus effects, especially for the topic of COVID vaccinations. These are mostly driven by the disproportionate impact of selected primary sources, so selected scientific papers rather than secondary sources. We also found an increase in anti-consensus users about a year into the pandemic, which could potentially be another potential driver around these misrepresentation of science. And we also find that in qualitative terms, COVID-19 science discussions can actually range from misrepresentative cherry picking to in-depth methodological discussions. So the picture I've painted, I know, is quite bleak, but there is a little bit of light in the tunnel because some Twitter and related platforms can actually be used to perhaps educate the public more on the scientific process, and that may be something that I guess is an optimistic outlook for us all to take forward. And I just want to conclude with some of the implications of this work. And I would just like to say that misrepresentations of science is not really a new thing. So this is what Kata had to say on the anti-vaccination movement back in 2012. Right? So Kata said, tactics and tropes that are commonly used to argue against vaccination include actions like skewing science, shifting hypotheses, censoring dissent, and attacking critics. Now, all of these things are things we also saw in the COVID-19 context. And crucially, something that I found really interesting from this quote, Kata also says anti-vaxxers basically frequently make claims such as not being anti-vaccine, but pro-safe vaccines. And I'd just like to invite you all to think about how many times you've heard people saying, I'm not anti-vaccine, I'm anti-COVID vaccine, because supposedly these vaccines are not safe. And so we actually see the adaptation of decades-long anti-vaccination tropes that were actually quite fringe back then, now making their way into the mainstream in the context of COVID-19. And this can actually have massive implications for trust in health establishments. And this is kind of what I wanted to touch on here, is that false consensus ideas may still persist to this day, right? So you may still hear people saying things like, we were right all along, or scientists lied to us, or this scientific health establishment is corrupt. And these ideas may actually further drive down trust in health institutions or institutions more broadly, right? So these false consensus ideas that still persist are still presenting challenges today because they are driving down trust, because it provides some kind of perceptive evidence in the minds of people that are misinformed to mistrust health institutions because they believe that they weren't really reporting on the actual science. It may also lead to the endorsement of contrarian figures as kind of beacons of truth. Again, going back to that starting slide, we see that very occasionally people that could be perceived experts are really the sources of this misinformation. And occasionally they can also be put in positions of power to actually look after health institutions, et cetera. And people that subscribe to these false consensus may celebrate that as kind of an effort to further uncover the truth. But really, this is mostly just a further obfuscation and ignoring of the wider consensus on scientific issues. For us, implications for us as researchers, I would argue that we may need to start looking into designs for more effective communication of actual consensus, or in cases where this is not really possible, at least highlighting the existence of false consensus in these cases to effectively make the case that when you're reading a secondary source, that is not really an accurate representation of the state of the primary sources in this space. And so, again, we need, I think, to start looking into ways of highlighting this difference between primary and secondary sources, because, again, a single paper reported by 1,000 different outlets is still just one piece of evidence for any given topic. So we kind of need to look at this primary source. And of course, in science, we already have tools for that. We have meta-science studies, we have meta-analysis, we have systematic reviews, and even meta-analyses. But finding ways of actually doing that among public circles as well is, I think, quite a worthwhile endeavor. And so I will stop there. Thank you very, very much for your attention. This is the QR code for the full paper if you're interested in reading more about it. And I'm looking forward to your questions.
Thank you so much, Alexandros, for an amazing presentation. It really shows how much work you've invested in this topic. It's really amazing. We start getting questions already, but for those who didn't yet pose the questions, please do so. Now, let me read the first question from Bernie Hogan. It says, magnificent work. Given time limits, I wanted to ask about the timeline of contrarian users joining Twitter. There is a tendency to assume it's coordinated, but I'm wondering how much we can detect it being induced. That is, people feeling they can't speak their contrarian ideas on Facebook and shift to Twitter. This can be contrasted with bots and disinformation actors like interpretations.
That's a fantastic question. It's something we have also grappled with quite extensively, and I actually fully agree that that is another very potential explanation behind this kind of surge of signups. Generally speaking, we've done a little bit of work, not specifically on COVID-19, but generally on migrations from sites to other sites. For example, communities getting banned on Reddit and then making their own websites and migrating there. So there could always be some kind of outside event that drove that migration. And again, it's very likely that this was just organic, or perhaps equally likely it was coordinated. We did try and get some data to look at the wider activity of these users and whether they were specifically focusing on COVID-19, whether they kind of were exhibiting any kind of trolling behavior. And unfortunately, we weren't able because at the time the Twitter API had shut down. I think this is a very interesting question. It is something that I would personally have liked to examine further by just looking at the specific users and their wider activity, not just in COVID-19, but generally speaking, if they're talking a lot about free speech, for example, and how that free speech right is being violated, I think this would be good evidence of what Bernie is saying. But yeah, I fully agree. And I think, unfortunately, we kind of did leave that kind of open to interpretation in the paper just because we couldn't get the data to make a conclusive, claim to that. But it's a great question.
Thank you. There is a next question from Calvin Cheng. Thanks very much for sharing. This is a super interesting and insightful. I have a specific question regarding severity of the misinformation that are driven or misled by actual scientific papers. Do we have a rough idea that how much misinformation percentage that actually cited a preprint paper? My intuition is those spread misinfo but cited a scientific paper may be the group that more willing to accept corrections for misconceptions than those who don't or citing problematic sources. Thanks again for the presentation. Appreciate it. Super clear and inspiring.
This is also another great question. I'm just trying to make sure that I'm getting this right. So whether this is about them citing preprints as opposed to published versions, or is this about whether they actually cited the source, so the link to the paper effectively?
So ideally, I would wait for Calvin to comment on that. But my understanding was that, yeah, we are contrasting preprint versus peer-reviewed papers,
right.
But that's
right. Great. Yeah. So the short answer to that is we actually did sort of a robustness check where we only limited the set. We only derived consensus based on the published literature, and we found wildly similar results. So there was a little bit of deviation, but nothing really to signal that it made a difference whether the paper was a preprint or published. I should also say that there were some published papers that got quite a bit of pushback from the scientific community itself, though. So, it's also a case of actual quality of studies. One particular study I remember on hydroxychloroquine later went on to be published, and we saw quite a lot of science communicators saying things like, why was this published? So, there was quite a bit of pushback from the scientific community about certain things. But in terms of whether they cited preprints or published versions, it didn't really make that much difference. It was quite consistent.
Thank you very much for that answer. Calvin, if you'd like to follow up with some clarifications, please do so. He just confirmed, yes, thanks very much for clarification. Perfect. Bernie mentioned that he have read the paper and get back if there is any further ideas. Thank you so much for that. Let's see whether we have any further questions. I would use the chance while we have a little pause here. Maybe I missed that in your presentation, but once again, how do you explain the peak of the sharp increase in signups of contrarian users after March of 2021?
Yeah, it's that's again very related to Bernie's question, I think, and it's we weren't really able to trace that back to any particular events, mainly because we only had the activity of these users with regards to citing COVID papers. So we didn't really have the whole data set for COVID-19 in general. It was just about papers. One of the activities we found these users engaging in was the amplification of already prominent contrarian voices. So that's really the only thing we could speak to, is the fact that they kind of came together and they were more likely to effectively share tweets that those people were sharing, these prominent voices were already sharing, and they were quite consistent in doing that as well. So the analysis, to give you a little bit more context, the analysis we performed specifically whether these new signups were basically more equal to each other in terms of how many retweets they were posting. And they were indeed more equal in the number of retweets that were posting. It wasn't like this massive power law distribution we tend to see. But at the same time, these retweets they were posting, they were very skewed towards specific sources. So they were mostly retweeting people that were already prominent voices in this cluster. And so again, we can't really speak much about the signups themselves. I think there's a lot of very good and equally plausible explanations, but at this point, it's all plausible. So unfortunately, I can't really provide a firm answer to that, whether it's coordinated or not.
Yeah, so one of the explanations is like a network effect. So just
Yes, exactly.
Thank you. So we got another question from Bashak. Given how challenging it is to access data on X right now, are there any platforms you're considering exploring in your further studies?
Another really, really great question, one that I think everybody's been wrangling with for the past 2 years or so. Yes. So at the moment, a lot of my work has already focused on Reddit, and it is a platform that I'm planning on continuing work on. There were also quite a few problems with Reddit's API being pulled. I am aware of some efforts right now to actually rectify that, and there are already actual torrents of Reddit data available. So I'm hopeful and optimistic that in the near future, we'll get another push-shift API that will allow us to continue work on Reddit. Blue Sky is also now another platform that has recently opened. We don't really know much about it yet, so a lot of the work is quite nascent on that, and I'm actually quite excited to delve into that space as well, mainly to see how well it mirrors Twitter's behaviors in terms of just network effects, not necessarily the topical discussions. So Blue Sky and Reddit, I think, are the two main platforms at the moment. There's also been some recent dumps for the US 2024 elections around, for example, on X and Telegram. So there's also some space on those platforms, but I think it's a question that would mostly be driven by what we're trying to answer. So, in cases where I would like to study labeled behaviors of users, so whether they're engaging with politics or entertainment or something else, I would probably opt for Reddit in those cases. In cases where I'm trying to look specifically into network effects, I think Blue Sky is actually quite an interesting platform to do in that respect. And we will see how that goes in terms of the research outcomes. I think we should expect a lot of paper streams on that in the near future.
Thank you so much for that. The next question is from Audrey Harroch. Sorry if I mispronounced that. Thank you so much. This is fascinating. Do you have any insights into how the scientists themselves navigated the misrepresentation of their results? Also, how could the misusage by Twitter users to some extent represent controversies in science, especially considering that knowledge and consensus were not fully stabilized at the time? I should perhaps mention that I'm speaking from a French perspective, where the controversy surrounding sorry, I cannot read that, deeply hindered our understanding of COVID-19 related science for a long time.
I really, really like this question, especially because I think it touches a little bit also on the country-specific conceptions of how scientific institutions also navigated it. And I think the original hydroxychloroquine paper did come out of a French lab, and so yeah, France was quite on that in the beginning. So we did find quite a few cases of scientists actually pushing back against claims made about their own papers. Most of those were of the nature that I showed in the presentation. So them coming out and saying, these findings are cherry picked. This is not what we found in the study. Please stop saying that. But unfortunately, they almost never gained as much traction as the actual misinformation about their papers, which is, an age-old problem in misinformation corrections. We also, funnily enough, found sometimes science communicators would maybe say something that was a little bit clickbaity, and then you get authors trying to correct that. And that was another case where we saw that. So there was some effort on the part of authors to try and correct these misperceptions. Unfortunately, I don't think they were very effective, just because the scientists on Twitter don't really have these massive followings. And yeah, in terms of the stabilization aspect, that was also a really, really good question. So in regards, especially with respect to drugs, the FDA even actually provided some emergency use authorization for a drug combination between azithromycin and ivermectin. And that received a lot of backlash from the scientific community because there was not enough evidence at the time to do that. And they had to pull that quite quickly. So, even the conception of, official guidance and how accurate that is, I think it's a really, really interesting thing to take into account. We set that official guidance towards the end of our collection period when, the science was at least a little bit more established. But during that time, official guidance actually differed wildly. So I think it's hard for scientists to navigate that, both in terms of correcting the misinformation, but also, in terms of trying to convince official institutions to just do and fund more studies on specific aspects of that. Bit of a roundabout way of answering it, but hopefully that covered it.
So now we're getting more questions, so let me read them. Interested in uncertainty tolerance and the presence of contrarian opinions. It's evidence that people apply motivated reasoning and will thus cherry pick. But I'm wondering about how the assumption of bad faith rather than greater uncertainty tolerance has inadvertently strengthened contrarian opinions. So some people saying we need consensus now, and others feeling suspicious about this need to conform to an emerging consensus. Related to the previous question, some cultures seem generally suspicious of authority, which isn't a bad thing, but having it filtered through trust the science attitudes, which raise the contrarian's spidey sense.
Yeah, I think, again, that's absolutely correct. So the first part, in terms of the uncertainty tolerance, I think it's difficult to really draw the line between when it's just uncertainty tolerance and when we actually go into the bad faith area. One of the reasons why we speak about this idea of bad faith accusations is because, again, there are times where, again, an example from the actual study, we found a paper where, they outlined their grants, right? So their funding sources, and then they specifically said, these funding sources had absolutely nothing to do with the study design. They just gave us the money to make this possible. And then you have people saying that, oh, these people were paid by this entity to actually go out and find exactly these things. I think it really comes down to how these, if it's not really systemic, but it's going into the area where you're actually now targeting specific named people, I would argue that is good evidence of bad faith accusations rather than uncertainty tolerance. But I think there's also quite a different aspect to that, which is the systemic aspect. And so in that case, I think a lot of people, especially in countries that are perhaps a little bit more repressed, would be absolutely correct to say, why should I trust this institution? And so, filtering that, as you said, through this trust the science voice would not necessarily, have the desired effect. I would acknowledge the limitation in this particular case that I'm coming mostly from the perspective of liberal democracies, and we mainly examined liberal democracies in this particular work. But I would not for a moment argue that this would generalize very well, even as an ideation across the entire world. So I think that's a really, really keen observation.
So another question is again from Calvin Cheng, and it's again about strategies. So another general question, maybe a bit of topic. In the qualitative analysis part, how many did we include in this study? And when we code the misrepresentation, how it is coded? What do you think of the LLM's assistant deductive coding of this task? For example, ask LLMs to interpret papers funding.
Yeah, so so in the qualitative analysis, I suppose we're talking about the last part of the study. So there was actually just 13 papers that we looked at in that particular case, and there were thousands of comments on those papers, thousands of tweets about those papers. And again, that kind of came out of the fact that we were specifically focusing on papers that were saying one thing but were picked up by the other camp, so to speak. So the misrepresentation, we started very open-ended. It was open-ended coding. It was basically thematic coding into chunks. So when we're talking about the misrepresentations, we weren't really coding that to begin with. We were mostly just coding thematic comparisons between claims in the paper and then claims in the tweet. And so we would then derive, we're coding that either discrepancy or agreement in the papers. So we're really coding the purpose that the tweet was using the paper for. So you can imagine that was the kind of strategy in terms of the coding. In terms of the LLMs, I think there's definitely been way more way more advancement in that space since we concluded the study and when we collected the data. So I think now maybe they would perform definitely much better. Back then, we also experimented with a few LLMs to do that for us, and it's because it's a very, very specialized field. And so we found that the performance of the LLMs at the time was not really up to par with what we wanted, because a lot of the claims, a lot of the terms that were being made in the papers were not things that they would have encountered very often in their training sets. So if they're talking about specific proteins or specific, it takes a lot of specialized knowledge that the LLMs cannot really tap into. So I can't really speak to how they would perform now, but back then we opted to just do the human approach because we didn't really trust the LLMs.
Thank you for that. And while we're approaching the end of the seminar, I'll use the chance to ask another question myself. So this result might be disturbing. So the science gets misrepresented on social media. But policy-wise, do you have any suggestions for the platforms to counter this misrepresentation? And as a second half of this question, there might be different there is a big discussion about different policies, but strict policies can actually lead to marginalization of people who have opposite views and migration to other platforms. So taking this into account, do you have any suggestions for policy regulations?
Yes. So again, a really, really good question. I think platforms have made a little bit of headway with some interventions, like when you're trying to share a link you haven't opened, they will give you a prompt and say, you haven't read this. Are you sure you want to share that? And they tend to be at least somewhat effective in stopping sharing of unverified news. And the first step would be to just test interventions like that. It would, I think, take a lot of investment into specifically training models to detect when people are talking about science in particular, but perhaps there could be space there to train general purpose models to just, infer whether how much something has been filtered through secondary sources before it's reached you. And I think, it's kind of a broken telephone game where at the end of it, you hear something completely different from the primary source, but it's still the primary source being cited for that. And that's a massive problem. I think it's not just a problem with science. I think it's a problem with any kind of claim that's being made where people are taking words out of context from a speech or, from a news article, and they're saying, this is what they're trying to do to us. So I think, for platforms, there should be, I think, some investment into trying at least to come up with interventions to flag up this idea that you're getting your news from this secondary source that's summarizing this in a wildly inaccurate fashion. And there's a lot of space to intervene on that with the blueprints that they already have with regards to, here's a prompt telling you that you're trying to share something that's coming from a secondary source. Maybe cross-check that first. And can you repeat the second part of the question? Sorry, I've been talking for a bit too long and I forgot.
So it's more or less covered, but I just mentioned that some of the strategies which might be too strict don't solve the problem, but marginalize people with against mainstream opinion, which is dangerous in itself.
Yeah. So I think, yeah, that kind of goes into the space of agency as well. So if you just outright ban people from talking about specific papers, that first of all, that I would completely disagree with that. And secondly, it would, I believe, have the exact opposite effect, because again, coming back to what Vernie said earlier, you know, if we're just shouting people trust the science and then here's the science, we're giving it to you, I think that's quite an authoritarian take on how we are discussing this. So yeah, any intervention we come up with, I think, should always respect user agency, and just, you know, maximize just effectiveness against that user agency.
Thank you. So we're really approaching the end of this seminar. I think you answered all of the questions. Congratulations on having completed such an important and big work. And we will be following your work and wait for more of your research to be published. Thank you so much. Yeah, have a nice rest of the day. Thank you so much to everyone who joined us today.
And thank you for inviting me, and thanks to everyone who attended. Thank you.